Okay, so let's use this information about the sampling distribution for difference in means now to come up with a method for constructing a t-confidence interval for a difference in two independent means. So now I've got random variable xi's that are coming from one normal distribution, and we've got a sample size n1, and then we have a second batch of values that are picked from a different normal distribution, which is independent from the first. And we're going to pick n2 values from that for that sample. And what we want to do is approximate the mean of the difference of population means mu1 and mu2. So we're going to take a similar approach. So the cutoffs for this are going to be equal to, we're going to start our estimate with what is the difference in our two sample means, and then we need to build some margin of error into that estimate. So recall that this stuff over here is the margin of error, and we're going to use the fact that the variance we just proved in the previous slide was equal to the variance of the first population over n1 plus the variance of the second population over the sample size of that. And since we don't know what these variances are, we use the two sample standard deviations. And since we don't know what the variances are, that's why we use a t-distribution again. So it pretty much looks exactly like what we did for a single mean, except now our statistic that we start with is the difference in our sample means, and we're going to adjust the standard error to use this new formula to estimate the standard error. The t alpha over 2, that's the same as before. And so one thing that we need to be careful about is that when we found this t alpha over 2, it depended on how many degrees of freedom do we have in the problem. And that depended on how large was your sample. But now we've got two samples, n1 and n2. So how do we find out what the right degrees of freedom would be to use for this t-distribution? So we'll kind of talk about it. First, if you're not using technology, then informally, it's not too bad of an estimate to pick the smaller of the sample sizes and use that as the basis for calculating the degrees of freedom. So I would say which of these two is smaller, n1 or n2, and then my degrees of freedom are going to be the smaller sample size minus 1. That's a rough approximation. We can get a slightly better estimate for how many degrees of freedom using what's called Welch's approximation. This is not something I would ever ask you guys to calculate by hand. So this is something that there's a nice formula for it, and R has built-in capability to do this when you run a t-test in R. But in case you're curious about where the degrees of freedom come from in R's calculation, it comes from using what's called Welch's approximation. And so when we're working with estimate for difference in two means, usually what we're interested in is whether or not there seems to be some difference in these two means. And so when we're interpreting our confidence interval at the end, what we might want to look for is whether or not 0 is inside of our confidence interval. And so if the value 0 is inside of our confidence interval, then that would be a plausible value for the difference. So in other words, when 0 is inside of our confidence interval, we can't be certain that there is a difference between these two means. If our confidence interval contains only positive values or only negative values, then that gives us a pretty good indication that there is a difference between these two population means. If we're working with really large data sets and we don't want to do these calculations by hand, then again, we can still use the t-test command in R the same way we did it with one sample, except now we would enter where is your first data set, what is your second data set, and the rest of it would be the same. So on the very last slide here, we're going to take a look at an example and see how we can construct a t confidence interval to estimate a difference in two population means.